Hello. The objective of this video is to show you how to use the unit circle to evaluate trig functions. So the key thing that you need to be able to do is recognize the angle, either in terms of degrees or radians, and then you need to know the point for which that angle intersects the unit circle. So we're going to start by using the angles that we learned with right triangle, that is the 30 degrees, 45 degrees, and 60 degrees. And we're going to use that to actually get a lot of the values on the unit circle. All the others you can really use your calculator, and you can even use your calculator for these, but it would be very helpful to you if you can commit these to memory. So let's first talk about some points on the unit circle that we know. And I'm just going to work in the first quadrant, and then we'll go around to the other quadrants. So we know this point on the unit circle is what? Remember that the radius is 1. So this point is 1, 0. This point here is 0, 1. Now the way that these are subdivided, this middle line here represents a 45-degree angle. And if you remember, we learned what the cosine and sine of a 45-degree angle were with right triangles. We learned that the cosine is the square root of 2 over 2, and the sine is the square root of 2 over 2. Now we also have a 30-degree angle and a 60-degree angle. We learned that the cosine of 30 degrees is the square root of 3 over 2, and the sine is 1/2. For 60 degrees, we learned that the cosine of 60 is 1/2, and the sine is the square root of 3 over 2. Now, do you recall what these are in terms of radians? Yeah, 30 degrees is the same thing as pi over 6 radians. 45 degrees is pi over 4. 60 degrees is pi over 3. Well, what is this? I didn't really talk about this angle here. That's 90 degrees, right? And 90 degrees is the same thing as, in radians, pi over 2. And what about this angle whose initial side and terminal side are the same? So this would be at 0 degrees, or you can think about a full rotation, an angle of 360 degrees, or 2 pi radians, has a point here, 1, 0. So notice that there's a pattern. You can look in the x values. We have square root of 3 over 2, square root of 2 over 2, square root of 1, which is 1 over 2, square root of 0 over 2, which would be 0. And in fact, 1 is really square root of 4 over 2, because that's 2 over 2, or 1. And then for the y values, we're counting in the reverse direction. So there is a real pattern here. Your key thing is going to be able to remember the angles that correspond to that. Now, what will that do now for the other side? Well, everything else is basically going to be the same values except for the signs, right? This point, if you think about being a reflection across the y-axis, is really negative 1/2 square root of 3 over 2. And this point here is negative square root of 2 over 2, square root of 2 over 2. This point is negative square root of 3 over 2, 1/2. And we know this point is negative 1, 0. Well, what about the angle measurements that takes us to? Well, the middle line are always multiples of 45, right? So if we think about 45 and 90, if we add 45 again, that angle would be, what, 135? And then if we add 45 again, we would get 180 degrees. Okay. The other ones are multiples of 30, right? 30, 60, 90. Then we would get what? 120. And then 150. And 180. Now you can also think about in terms of pi, in terms of the radians. And the best way I think to do this is to count the multiples. So here we have, let's do the middle ones first. 45 is 1 pi over 4, then 2 pi over 4, then we would have 3 pi over 4, and then 4 pi over 4, or just pi. Okay. Now for the ones that are multiples of the 30, so we have 1 pi over 6, 2 pi over 6, 3 pi over 6. So this would be 4 pi over 6, but 4 pi over 6 is 2 pi over 3. And then 5 pi over 6, and 6 pi over 6, which is pi. Then we can rotate again in the third and fourth quadrants. So again, now we're going to reflect over the x-axis. So this point corresponds to negative square root of 3 over 2, negative 1/2. Then we're going to have a negative square root of 2 over 2, negative square root of 2 over 2. Then we'll have a negative 1/2, negative square root of 3 over 2, and then the point 0, negative 1. And let's go ahead and fill in for the other part to reflect again across the x-axis. That's going to be 1/2 negative square root of 3 over 2, square root of 2 over 2, negative square root of 2 over 2, and this last one here would be square root of 3 over 2, negative 1/2. So continuing to mark our angles, let's go back to the pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This is going to be 5 pi over 4, 6 pi over 4, which is really the same thing as 3 pi over 2, and then 7 pi over 4. Now what about in terms of degrees? If we add 45, 90, 135, 180, if we add 45 to that, we get 225 degrees. If we add 45 to get that, we get 270 degrees. Adding 45 gives us 315 degrees, and then also 360 degrees. So this would be like 0 or 360 degrees here. Okay. And now continue with our multiples of pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, but 8 pi over 6 is 4 pi over 3, 9 pi over 6, 10 pi over 6, which would be 5 pi over 3, and 11 pi over 6, or 12 pi over 6, which is also 2 pi. Okay. Now in terms of adding 30 degrees around, so we have 180. If we add 30 to that, we get 210. If we add 30 to that, we get 240. Add 30 is 270. Add 30 is 300. And add 30 is 330. Okay? Now, I actually have a copy of this that you can print out from these notes, so don't get panicked and think, oh my gosh, I'm not going to get all this done. There's a really nice copy that has all this information on there. But now we can use the unit circle to evaluate trig functions. So if I wanted to ask you to find what is the cosine of 7 pi over 6. Well, as long as you know that it's one of these kind of standard angles, 7 pi over 6 is here. The cosine of that is the x value on the unit circle, which would be the negative square root of 3 over 2. What about the sine of 3 pi over 2. Okay, again, you need to think x is cosine and y is sine. Think about alphabetical order. Okay, so sine of 3 pi over 2 would be -1. What about if I ask you to find the tangent of 2 pi over 3? Okay, the tangent would be what? Sine over cosine, so you'd have to find the sine of 2 pi over 3 divided by the cosine of 2 pi over 3. So the sine of 2 pi over 3 is what, square root of 3 over 2 divided by the cosine, which would be -1/2. And so that gives us negative square root of 3. Now, I could also find other things like cosecant and secant by doing the appropriate reciprocal or cotangent. Let's do some that maybe is a little bit different. What if we wanted to find, let's see if I can squeeze it in here. Let's say I wanted to find now the sine of negative pi over 4. So now I'm going to go in the clockwise direction. Negative pi over 4 would take me to the equivalent of 7 pi over 4, right? So the sine of that would be negative square root of 2 over 2. What if I wanted to calculate the sine of negative 5 pi over 6? Okay. So starting at the 0 and counting in the clockwise direction, the way I would do it is count by the pi over 6. So we have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Now remember, I'm counting in the reverse direction. So the sine of that angle would be the y value, which is -1/2. Okay? What would the cosecant of pi equal? So that would mean to do 1 over the sine of pi, and the sine of pi is 0, so we'd have 1 over 0, which is undefined. So we cannot find the cosecant of pi. But what about the secant of pi? So that would be 1 over the cosine of pi, which would be 1 over -1. So that is -1. Okay? So you need to have the ability to know the standard angles, be able to count to go either in the positive or the negative direction. And here is a handout that you can kind of use to print and study by. Notice that it has all of the angles in degrees and radians, and it also has the ordered pair that's on the unit circle, which in turn gives you the sine and the cosine. Notice that it has the coordinates and the signs of those coordinates. I've learned a saying through my years of studying, and it's this, that all students take calculus. And what that tells you is the quadrant that something is positive. So all of our 6 trig functions are positive in the first quadrant. Only the sine and its reciprocal are positive in the second quadrant. The tangent and its reciprocal are positive in the third. And the cosine and its reciprocal are positive in the fourth. So that might help you. Okay, I'm going to erase that so that whenever you print this off, you won't have that decluttering that space. Okay. So if you have any questions on how to use the unit circle to evaluate trig functions, please don't hesitate to contact me. Thanks.